Welcome to Understanding Gradle. This time we look at a widely used functionality of Gradle, which is copying and packaging files. Folks that automate their whole software product, build and release process with Gradle will most likely need to customize such functionality in their build. And that's what we are looking at today. Let's jump right into an example. Here I have a simple project that builds a Java application. So here I have a Java class with a main method, and in the build file I've defined a dependency which we use in our implementation. And then I use my own application convention plugin, which we are going to write in this episode today. So let's go into the definition file of this convention plugin. We would like to provide tasks to install or package our Java application. But instead of using Gradle's application plugin that has some pre-configured functionality for this, we just use the basic Java plugin because we would like to define the functionality for installing and packaging our application ourselves, as we want to customize it to our needs. We would like to have two tasks, one called install and one called package. The install task should copy all the files we need for our application into one location. These files are our own compiled code and the dependencies and some metadata and a start script. To copy files into a location and make sure there are no stale files from the previous build run in that location, Gradle offers the sync task implementation. So for our install task, we can use this task implementation directly and don't have to write our own tasks or something like that. There's also a similar task called copy that would blindly copy the files into the destination, keeping any old files in the destination if there are any. Therefore, you should use the sync task whenever possible, as it follows the Gradle idiom to always have a clean output location for a task which is not filled with files or anything from some other tool or other task. There could be special cases, for example, if you copy files outside of your build folder for a final installation where you need to use the copy task. For the package operation, there is a task called zip that we've used in previous videos already. As the name says, it will construct a zip file for us. Now, how do we configure these tasks? For any task that combines a set of files to put them into a new location, Gradle has a common configuration model called copy spec. Let's say we create a copy spec called install, and in the spec we can now say which files should go into the destination and where they should go there directly. For example, we would like to add some meta information to our application package, like license files, etc. In our example, we have a version.txt file in our project that we would like to add. All this information should go into a subfolder called meta. For this, the copy spec has the into construct. So we can define a path here into which certain files should go, and then in the configuration block, we can say which files should go into this block. We say put the version.txt file from the root of our project in here. So this is an existing file that just needs to be copied or packaged. Then of course we want to have our own application as part of the package. This should go into the app folder. And here we say with the from statement that we would like to have the jar of our application put here. Instead of putting a path to the jar file here, we tell Gradle we want to have the output of the jar task put here. This is important because the copy spec will preserve all the dependency information, so Gradle will know that in order to get the jar task is needed to be executed first. So this is similar to how you should configure tasks in general, which we explored in the corresponding video. Then we also need the dependencies of our application in the package, otherwise our code won't run. We put this into the libs folder and we get the dependencies by accessing the runtime class path configuration that the Java plugin offers us through Gradle's dependency management. By this, Gradle will know how to get the files that make up the dependencies. For example, downloading them from a repository, putting them in the Gradle cache and copying them from there. Or building the jar files if a dependency would be another local project. As the last piece, we would like to have a start script to run our application in the root of the installation folder or the package. In the episode on implementing your own task, we have written a custom task to generate such a script. Let's reuse the task here. We add the task implementation. For details on that, see the video on that topic. And then we use that implementation to register an additional task that we call generate start script. The task is configured with the class name of our main class, and it needs a place where the start script is generated to. We put it into a temp location in our build folder because it's just an intermediate step for us. In the copy spec, similar as we referred to the jar task before, we now refer to our own task and say that the result of that task, the start script, should be put into the root of the installation or the package. Now we have a complete specification of how Gradle should compose our installation or application package. Now the only thing left is to use this copy spec in the configuration of our tasks using the with keyword, which we do in both the installation and the package task. Note that instead of defining a copy spec separately and then using a with, you could also define the spec directly in the task configuration if you only need it for a single task. In addition to this, for each task we need to define a destination directory where the installation or the package should be put. If we now run the install task, we see that in the install directory the files are now present as expected. We can also see that other files were created in the build folder because Gradle automatically ran all the tasks, like the Java compile task, that were required to build all the files we needed for our installation directory. If we run the package task, we get a zip file which has exactly the same content as the install directory inside the zip file. With the copy spec data structure, Gradle offers a flexible way to copy or package files, because it not only allows you to put file objects into it, but also reference other Gradle concepts like tasks or configurations from dependency management. It can be used to bind together everything that makes up, for example, your final application. If you would, for example, do this for a large multi-project and all of your sub-projects are part of the runtime class path of the application, calling the install task through the copy spec would automatically trigger the compilation and building of all your modules. There's more functionality the copy spec concept offers. Here are a few things you might need to tune your setup. The first thing we've already seen when we used one copy spec in two tasks is that copy specs are composable. That feature can also be used on the specs directly. For example, let's say that we want to make a distinction between the packaging spec and the install spec because we want to package more files than we need for the installation. Let's say everything in our meter folder is not needed for the installation, but just for the packaging. So we can move this part out of the install spec into the packaging spec and tell that the packaging spec is based on the install spec, which we do again by using the with keyword. Another thing you sometimes need is that you get a whole directory tree and then you want to filter out certain files. For this, the copy spec offers the option to define your own filter function or to use ARN style include or exclude statements. If files come from a location that's out of your control, like the external dependencies we downloaded, you might want to rename them in the final location, which can also be done as part of the copy spec. You can define a rename closure, for example like this, to strip the version part of the jar file name. Note that such operations are scoped to the into or from block you use them in. Therefore, you have very fine-grained control over such tuning. The last thing I would like to show is that you can also extract zip or jar files during the copying process. For example, looking again at the external dependencies, if we don't want to zip up the jar files, but instead would like to take out the class files and use them directly, we could do that as part of the spec. Now this can become tricky if you deal with multiple zip or jar files like we do here. In such a case, where we have a configuration like the runtime class path here, we can use the element methods to map the configuration to a provider of a list of files. And then we can write a mapping function to map each single zip file lazily to the content of the zip file. So that in the end, in the final location, we will get the extracted class files instead of the jars. For more information about such mapping functions, see the previous video about the provider concept in Gradle. In a more or less standard project setup, the things we looked at so far should be sufficient to set up custom installation or packaging of an application, or for dealing with other files like copying or packaging reports the build produces. Therefore, the following is something you might only need if you develop your own task because you have specific automation concerns you would like to implement in Gradle. Now, assuming you have your own task implementation, there might be situations where you would like to do a syncing or zipping as part of the logic that you implement inside your task. So you don't want to do the sync as a separate step, but you would like to do it as part of the logic you implement inside your own task action. You could do that kind of from scratch by using standard Java file operation APIs or libraries, but Gradle also allows you to use the same mechanics sync and zip task use inside your own tasks. For this, it offers a so-called file operation service that you can inject. And on the service, you have the same API, so basically the CopySpec API, that we also have in the sync or zip task. So you can say sync to do syncing of files, and this can then be done somewhere inside your own code as part of your own task implementation. Before we end, I would also like to show an anti-pattern that I've seen in many builds. If we go back to our convention plugins and use code completion, we see that instead of registering tasks and so on, there's also a copy or sync statement just available here. This is actually a method on the project object, so the representation of our project in memory. This is something that was added in early Gradle versions, which can nowadays mess up your whole build configuration. If you use this method, it's basically the same we just looked at with the file operation service. So in the place you use this method, the copying will be done. So you would put action code, which belongs into task actions, into the configuration phase of Gradle, which is most likely not what you intended. To move the code out of the configuration phase, you could put this copy statement into your own task actions, which you can add dynamically to a task using the do last operation. That is something we'll look at in more detail in the next video. By this, you move the actual copying code back to the build execution time, but because the sync here is a method on the project object which holds the whole configuration state, this is a mix between configuration state and execution state, and doing this no longer works if you use the Gradle configuration cache. In my opinion, this shouldn't be allowed at all, and the editor should already give you an error here, which might be something that future Gradle versions do. In this video, we learned about the concept of the CopySpec in Gradle and how it is used to configure the sync or the zip task to copy or to package files. The CopySpec is a flexible construct. It allows for composition, so there is no need for repetition if similar configuration needs to be used for multiple tasks dealing with files. And it comes with tuning functionality like filtering or renaming files. And it integrates with other Gradle concepts, allowing you to not only add static files, but also results of task execution or dependency resolution to a CopySpec. That's all for now. See you next time.